Hi folks, this is Calc 2 Quiz 10. We're given a polar curve, r equal 2 minus 4 cosine theta. We're asked to sketch a detailed graph of this curve, including the tangents at the poles. Now, when I go to graph a polar curve like this, I always go back and graph the rectangular counterpart. Y equal 2 minus 4 cosine x. So, since I haven't messed around with the inside of the cosine function at all, I've got my standard quarter marks at 0, pi over 2, pi, 3 pi over 2, and 2 pi. I substitute 0 in, I find that I'm already down at negative 2. I substitute in the pi over 2, I'm up at positive 2. I substitute in pi, I'm up at 6. The 3 pi over 2, I'm back to 2. And the 2 pi, I'm back to negative 2. So now I connect the dots in the pleasing cosine fashion, like so. Now it's going to be important for me to know these x-intercepts. Those are going to be the places where the r value goes from negative to positive and vice versa. Those are going to be the places where we pass through the poles. In fact, those will be the tangents at the poles. And so to do that, I need to find the x-intercepts. So I need to figure out where 2 minus 4 cosine x is 0. That's the same as looking for where the cosine of x is 1/2. And those are at pi over 3 and 5 pi over 3. So then when I go to graph my polar graph, the first thing I do is dot in these tangents at the poles. So I'm going to dot in the pi over 3 line. So that's supposed to be theta is pi over 3. And then the 5 pi over 3 line. Theta is 5 pi over 3. And now I go from one region on this curve to the graph and then transliterate that over to here. So between 0 and pi over 3, the radius, or the r value, starts out at negative 2 and goes into 0. If we had a positive r value, we'd be graphing in this region of the plane. But since the r value is negative, we're going to be starting back here, 2 units this side of the pole, and graphing from negative 2 into 0. And I'm going to use this as my tangent line there. So it comes in at an angle of pi over 3. From pi over 3 to pi over 2, the r value goes from 0 back up to 2. Since it's positive, I'm going to be graphing in this area, in this region of the plane. So I'm going to come in and go through that point. Doing all that well for me here. Crosses there. From pi over 2 to pi, the radius goes from 2 out to 6. So from pi over 2 to pi, I'm going from 2 units out from the pole to 6 units out. So I'm doing this. Then from pi to 3 pi over 2, the r value goes from 6 back down to 2. So now I'm pulling inwards. So I'm getting closer to the pole. From 3 pi over 2 to 5 pi over 3, the r value goes from 2 down to 0. So I'm pulling myself in from 2 units away from the pole into the pole. I'm going to do it at this angle here. I'm going to use that as my tangent line, like so. And then the last leg of the journey, from 5 pi over 3 to 2 pi, the r value is negative. So instead of graphing over here, I'm going to be graphing here. And that's going to connect this thing then back up to where I started. So we have one of these, I believe they're called limicons. I can't pronounce that correctly, but there it is. Now the second part of this take-home asks us to find the area of the inner loop. So it's kind of helpful to have this graph as a reference. If I want to find the area of the inner loop, I can look at what's going on here between 0 and pi over 3, which is this region here, between 0 and pi over 3, that's when I graphed this part. So to find the area of the inner loop, what I can do is find the area from 0 to pi over 3. That would give me half of this area here, and then double it to get the area of the inner loop. So we'll see that in part B. So the area between the pole and a polar curve is given by the formula 1/2 the integral from alpha to beta f of theta squared d theta. So what I'm going to do is take 1/2 the integral from 0 to pi over 3, 2 minus 4 cosine theta, quantity squared d theta, and then what I'm going to do is double that. So the integral from 0 to pi over 3, 2 minus 4 cosine theta squared d theta would then give me the area of the inner loop. So that'll do it for quiz 10.